You just chill and come upstairs. Harvey just came to hang out with us. What did I do, man? Come on, I got almost Maine up there. I got Aerosmith Psyche. Don't get mad at me. All right, cool. So you guys are good to go at home. I will see you tomorrow. And then, of course, you'll get your test on Friday. And so that's the deal. You guys have today in class, and then the same thing tomorrow. You just hop on for attendance, stick around and ask any questions if you have. Otherwise, take some time away from your screen. And then Friday morning, 7 o'clock, that's probably what I'll do. Like I have in the past, I'll send you a link to a Google form that will have everything. Some of them you can just click. You don't have to have any work required. Some of them you can just answer right through the Google form. You just type your answer and you're good. But if there is work required, just do that separately, handwritten, and then throw it up. Okay? So whatever you want to do today, sit there and work and just try your best and scroll through the solutions on your own or tell me what to scroll to. And then anything that stumps you, let's talk about it. Okay? We are out of here at, what, 55? So half hour or so. And at the end, I'm going to take like the last 6 or 7 minutes. I have something that I'd like to show you, just something I thought was kind of cool. It's got a lot of tricky stuff in it. Like I showed you that video with the water, right, and that like weird cool wave. So I want to expand on that. There's experiments that mimic that, but are also like that. But it's really, I don't know. It's super cool. So it's like a 6-minute video that I'll show you. So I'll stop us with like 7 minutes. And we'll decompress and watch something pretty cool and go from there. Okay? I got millions of videos like that. So this is just, you have some downtime. I want to show you. Yay, there you go. We're here. Hang out. Right? It's so sad. Even Finding Dory, they go to the zoo or the aquarium, right?
Yeah. I feel like they could have that because there's an ocean right there. This is all you ever know.
It's true.
That's analogous. In Disney movies. Well, yeah. Have you ever seen
Him? No.
Oh,
No.
How did you not like run away?
I don't know. I mean, he's just like looking around. He just likes to. I think he knows he's not on the ground either. Like I think he knows he's up. I don't know how, but right. There's nothing scary. Yeah. So they can be really fast. They are really quick. And what's cool about the way that lizards run is not the way that like people or dogs run, where like their legs go behind them. They go out to the side like this. And so like the legs and the arms are all doing. It's so funny to watch. No, that's like geckos, iguanas, yeah. Different family of lizards have that. They drop their tails when they're threatened. I had 3 leopard geckos.
My died so easy. Like that's not so sad.
So one of them was a runt, so he kind of got picked on a little bit. So he was the first one. But then they lasted a while. They lasted years. Yeah, they lasted a couple years. Philip, Seymour, and Hoffman is what I named my leopard geckos, because he had just passed away, so and he was the man. So, yeah, that was actually the nurse's son's bearded dragon. He graduated from Pondo 3 years ago and couldn't take it to college, because when you go to college, you can't take any pets unless they can live underwater 24 hours. At least that was my college's rule. You could have a fish, you could have a frog, anything that lives underwater 24 hours. So they can't get out and escape. So when he was going off to school, she sent an email out to the staff. Hey, does anybody want? I'll give it to you. Yeah. Free? Sure. And then of course I went to PetSmart and bought like $100 worth of stuff for his game. Bulbs and that, like that. I don't know where it went, but I had like this really cool like big dinosaur skull. But I bought this thing. It's affordable. This. They eat live crickets. But crickets are really good at hiding. And when I gave him to one of my students to take care of over break, a summer break. No, spring break last year, when it all went down. They're like, sure, I'll take him for the week, and it ended up being months and months and months and months. That student's mom like fell in love with him and like bought him all this stuff and like filled it with sand instead of like the felt. But the crickets would bury themselves in the sand to hide, and then they would stay there and then die. So it really wasn't worth buying live crickets because they would just die. So instead I have dead crickets and little what look like flaming hot Cheetos. And they taste just like flaming hot Cheetos. You guys should try them.
My brother was like one time opened the got the swim cricket cage and then all escaped from the basement and all over my bedroom too. It was so annoying.
Yeah, really noisy. They're all over the place. Super fast, and you jump super high. Yeah. What? Why? Cow? That's a cow question, yeah.
How do you get that from that?
That's really now. Negative. Why did I do that? Well, I saw that there was a sum right up top. And so I try factoring first. What number is that? 20? Okay. And so I've got like this term right there, right, the negative 2 sine x, and then I've got this term, the plus 2 sine x cosine x. And so I noticed that there were a couple things in common, the 2 and the sine x. And so I decided that, and this was just a first try, I was like, all right, well, let me factor it out and see what happens. But when I factor, I always pull out a leading negative if my first term is negative. Because then, like, so that negative right there, that was first. So I'm like, I'm going to pull that negative with me, because what it'll do is it'll make now my leading term inside positive. And I usually recognize factoring, or I just recognize things better when that first term is small. So I pulled out the negative with the first term, and so when I pull out the negative from everything, now that plus sign switches to the negative, right? Because I pulled out a negative. So, I mean, imagine multiplying this back together, negative 2 sine x plus 2 sine x cosine. So it does factor that way. And once I did that, like I saw that 1 minus cosine x in there, I was like, ooh, I like that. That's the kind of thing I'm looking for. Why do I care? Because I'm going to 0. Right? And I see if I see a factor that is a sine x or a 1 minus cosine x, and we're going to 0, I'm going to try to isolate. And so because I factored first, I knew that when I tried to break those fractions apart, I have to do it with multiplication. And so what I'm really trying to isolate when I do that is that. Like I was just trying to get that by itself because I saw that as a factor up top. That kind of set off some alarm bells. Ooh, that's one of my 2 trig limits I got to know. Let me try to find it. So I pulled that out in my mind first, but then I said, okay, well, what's left behind when I do that? And when I pull fractions apart with multiplication, I want to make sure that if I were to multiply them back together, I would get the step that I was at before. And so it's easy up top because it's, okay, cool, I factored. So there's the multiplication. So negative 2 sine x in one of the fractions and 1 minus cosine x in the other. But then I was like, well, how do I deal with the denominator? Well, it's x squared. Well, if I'm breaking the top apart with multiplication, I have to break the bottom apart with multiplication too. And I know I want one of the denominators to be x, because that's the 1 minus cosine x over x. I want that. I need that exactly. And so the other denominator was just the other x. Once I have the product of the limit of a product, now I have the product of 2 separate limits, and I just dealt with them separately. Right? The negative 2 times the 1, right? Sine of x over x, that limit is 1. So the negative 2 right there is this negative 2. This 1 is that limit right there. And then, of course, that limit is 0. So negative 2 times 1 times 0 is 0. Those are going to be the ones that I feel I'm going to break out the red pen and mark them up for sure. Yeah.
But how did you go from negative 2 sine and then just make that the negative 2 sine x? Like wouldn't it be 4? Like how did you just get rid of it?
Show me where. What are you talking about?
And like the
top row or bottom row?
Top row.
Top row. Okay, so starting here to here?
Yeah.
Okay. So the only thing I'm doing is I am factoring the numerator. The only thing I'm going to do from where it was given to my very first step. Okay. Let me do it out. I think you'll see it better if I talk to you. Okay. So numerator only. So I'm not going to write the limit or the denominator. Negative 2 sine of x plus, so one term plus another, 2 sine of x cosine of x. What do those 2 terms have in common? So I can definitely factor out a 2 sine of x, right? And what I would have left behind if I did that, well, okay, so here's my first term. So I took out the 2 sine of x, the only thing I have left is a negative 1. Okay, plus, and I took the 2, took the sine of x, so all I have left is this. But when I do that, it doesn't really help me in here. Like this is nothing to me. Cosine of x minus 1, which is what that really is, right, is not anything useful. But what I do know is if I could turn it into this instead, right? If I could have that limit somehow, if I could, like, because I'm looking for this limit, right? One of those 2 limits that I know is undefined because 0 over 0, but we proved those limits. Now I'm going to try looking for it. I'm like, wow, that's really close for a numerator. That's really good. And I'll see if I can find the denominator somehow once I get there. But let me focus on trying to create from this. Let me try to create this. So what's the problem? It's just the signs are wrong, right? It's supposed to be positive 1 and then a negative cosine x. This is the opposite. Let me pull out a negative. So that's kind of my mind process.
Yeah.
Try to get to there. Because then, okay, cool. If this is all over x squared, right? What I can do is I can break this one fraction into 2 because x times x is x. When you break it apart with multiplication, you actually break it apart, right? You factor things in and break them apart. When you break it apart with addition or subtraction, it's just, you just keep the denominator all the way through, right? Because I need common denominators in order to be able to add and subtract them together. But when you multiply fractions, you actually multiply everything together. There's kind of two different mindsets, 26 versus 27. Like 26, I'm like, I got to break the x squared apart because it's multiplication that I'm doing the breaking apart with 27. Again, what am I looking for? I was looking for that. I'm trying to find sine of x over x or 1 minus cosine of x over x. Because those are the two special trig limits that we had to like go through a crazy process just to prove. So now that we've proven it, now I go hunting for it. I'm going to go looking for that limit. And so I notice it's sitting right there. So I said, okay, let me see if I can get that apart. Well, there's nothing to factor there. Like, there's no way for me to factor that numerator to kind of isolate that. So let me break apart the fractions, not as a product, but then as a sum. And so I isolated that and that's that x over x separately, right? I had the x over x plus 1 minus cosine of x over x. Same denominator, just breaking apart the numerators in a way that is going to be useful. Like I didn't do x over x and 1 over x and negative cosine over x, because 1 over x, as x goes to 0, undefined. Cosine of x over x, x goes to 0, 1 over 0, undefined. Like both, like not wholes, but asymptotes. I don't want to do that. I'm trying to find rational limits. So I can put them. This is the hardest thing, probably. Because it's analysis. It's like, you know, like when you try to look at a 3D picture, you have to like relax your eyes. Like sometimes you like cross your eyes and then you have to like relax them to see. You guys ever done that? Like you put your face like really close to those 3D pictures, so your eyes are crossed, and then you move it away, and then like all of a sudden, as your eye gaze stops being crossed and starts being like straightened out, like a 3D picture appears. That's kind of how I feel with trig limits sometimes. I have to like cross my eyes, and then I have to relax them. To, like I see like tiny little pieces, but then I try to see the whole picture. Little pieces and the whole picture. Trying to look for a very specific. Yeah. Sure. Let's back up a little bit. There's one. Sure. What'd you put? So because it's a two-sided limit, not just a one, didn't have that little plus or that little minus, it can't be infinity or negative. The only time we can ever say that infinity or that negative infinity, we turn to the second page. Right, these are okay. Right, 6 from the left, yep, going down. 6 from the right, yep, going down. Now, it does not exist. It's always okay for those infinite limits. But look at alpha. Even though they're both going in that same direction, I cannot say that because of them coming from both sides. And really, like when I say negative infinity in that spot, I'm not really saying the right thing. It really should be does not exist. We just like to say that so we can see it a little better. Like I can close my eyes and like, oh, okay, cool. Going down, going down. I can see the picture a little bit better. It does not exist. It can be a lot of different things. With negative infinity or infinity, I can close my eyes and I can visualize it a bit better. Yeah, because from both sides, yeah, we are going down.
Or, well, actually, it's like that.
For which one? For J? So 1, 2, 3, 4, 5. So there's 6, right?
Oh, okay.
So 5, yeah, would be 3. The limit as x approaches 5, definitely 3. From the right, from the left, absolutely. As we approach 6, and I want to get really, 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 really close. And I kind of just said, well, let me go a couple blocks. Well, as I approach 6 from the left, down, 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 down. Let me back out so you can see.
For section 412,
yeah,
I think it's just the difference in cubes that's missing there.
okay, probably. Is that the? Let me see. So, yeah, I mean that's a rough one. That's why it's the last one in that section. That factoring is definitely the hardest. Difference of squares, kind of factoring. But really, like for me, what makes factoring sum and difference of cubes a little bit easier is always trying to figure out like what is really being used. Like, what is that base? So 27, okay, cool, that's 3, right? 3, 7. But like what are we gonna have to put here? Both the number and the power of x is gonna get us to there. Like what number cubed is 8? And then x cubed is x. So those are my two bases, right? A and B, if you wanted to think about it, right? When it's a cubed minus b cubed, binomial, trinomial, same, opposite, always positive. And it's a squared, ab. Same, opposite, always. So that just gives me the sign. But the a squared, b squared, that sequence we have. At least write it down and be able to use it. And so I know what my signs are going to be. Okay, same, opposite, always positive. And I just have to like use 2x and 3 as my two terms that I just kind of start dropping in. And with the first binomial, it's just 2x and 3, nothing I have to change. Right? But then this is a squared. Like all of 2x times itself. Then you take 2x and 3 and multiply them together. Again, I don't think of it like -3. That sign is taken care of by me doing my same opposite always positive. So I just take the positive. And then so that's my numerator. Plus minus 3, 4x squared plus 6x squared. Then we also have to factor the denominator. And that's that quadratic where a is bigger than 1. You see, like I'm doing some side work. Like I wrote, like above here, I wrote like 2x cubed minus 3 cubed, so I can just get myself wrapped around those. With the denominator, I was like, all right, I got to factor this thing too. Let me do that, and you can factor that however is convenient for you. Easiest way to do that, right? Two numbers that add to b multiply to a times c. So two numbers that add to -5 and multiply to +6, right? 2 times 3 is 6. So that's -3 and -2. That'll do that. And then I set up a quadratic, like factored version, as if it was just those numbers, right? X minus 3, x minus 2, like just plain old x squared. Now, factoring by grouping works. The 2 by 2 square works. Like however you want to do that is up to you, but I showed us a faster way that I actually learned this year, which is awesome. You set up those two sets of parentheses as if it was just x squared instead of 2x squared. Oh, too close, got fixed. And then divide those numbers by whatever a is. Just as kind of like a setup, little side work here. If the number goes in perfectly, 2 divided by 2, sweet. Okay, x minus 1 is one of those factors. If it doesn't go in evenly, like 3 divided by 2 is not a whole number, that denominator becomes your leading coefficient instead. Right, so it becomes 2x minus 3, because that 2 jumps in front. That 3 stays the same. I'm not going to change it. That 2 divided by 2 is 1. So like when there was a one before that, that was this one, 3x squared plus 8x minus 3. You factor that. So I said, okay, two numbers that add to b multiply to a times c. Okay, so I'm adding to 8, multiplying to -9. So what numbers do that? 9 and -1. And so I set it up. X plus 9, x minus 1, like I was factoring regular, like algebra 1. But because a is different, I have to divide by a and see what happens. Whatever happens, happens, right? Okay, cool. 9 divided by 3. Sweet. Perfect. X plus 3 is one of my factors. But 1/3? No decimals, no fractions. So that 3 instead, and that's the factored version. Now, do it the long way if you want. 3x squared plus 9x minus x minus 3. GCF of the first two. GCF of the last two. What do they have in common? What's left? There anyway.
I did the quadratic formula.
Well, that's solving for the x-intercepts. I mean, that would have been fine. You probably got -3 and 1/3. So then x plus 3 and x minus 1/3. Get rid of fractions by multiplying through by 3. That's the long way, that's for sure. Or you can do the 2 by 2 squared. 3x squared, 9x and -x, 9 and -1. And then that GCF in every row and every column. What's on the outside while you're back. Yeah. So lots of different ways to do it. I think that this is the best. Simplest. Nice. But they're all like this is this. This is that. They're all the same. You're just kind of hiding some of the harder math and in the background. And if you take BC next year, you will hear Lynch talk a lot about different kinds of tools. Sometimes it's just a hammer and chisel. Small changes that can make a big difference. Sometimes it's the jackhammer. Sometimes you just force the thing and see what happens, right? And sometimes it's like the tiniest little thing, right? So you have different tools in calculus to use what you need. He likes to use that analogy a lot. I like it too, because it's true. Sometimes it's just, you know what, I'm just going to knock this thing out. I'm just going to sit down. I'm going to do it the hard way. Because I know it's going to work. But calculus is a lot more about finesse than brute force. I made up 12 and I could not believe it was a whole number at the end. That was so cool. Because what I did is I thought of this difference of cubes, figured out what that leading factor was going to be, and then made that one of my quadratic factors so I knew it would divide away, and then picked that 0 as my xi. And just kind of crossed my fingers and hoped that 3 halves would work out nicely in the end. And did. 27 over 54, or 27 divided by half. All right, let me show you that video because I think we're out of here shortly. Stop. No, right away, absolutely. If you see like or the list of this, done right at the end there for the order that you choose to write it in is up to you. Like some of my classes did like the limit first, some of them define the function first. All right, let me show you this. I hope you like it. I think it's super, super cool. It's a video. It's like 6 minutes, so we'll kind of run right through the end. We'll let Grammarly teach us how to write first, because of course it's a Grammarly app. Okay. So I'll start you with that. Everything you're about to see is real. Remember the spirally, right, the water thing that we saw? You'll see that one in here. That'll show up a couple times. But there's other ones too that are just really cool. But he does it with like music in the background. So this guy Nigel Stanford did this video on cymatics. Cymatics is the visualization of sound.
The film you are about to see has no characters. If you spare a little of your imagination,
That's probably my favorite one.
it's a film to describe to you the effect of cymatic frequencies of matter.
It's definitely not cymatic frequencies is all trig. Everything has everything to do with the movement of sound. But it gets really cool. I've studied these. These are super cool. Again, that's not water. Water hooked up to a hose, but it's connected to his bass drum. His bass pedal, This is what this actually sounds like. And that kind of difference in frequency. All true, all real. Do not try this at home kind of stuff, but pretty awesome. Do that test with him. There you go. Have a good day, everybody. I will see you virtually, briefly, or as long as you want tomorrow. And then expect that test first thing Friday morning. We have all Friday for time. Let me know if you have any questions. Hey, security monster. How'd you do? Oh, good, you didn't.
I like save money for a quarter. I love my budget. Yeah, I was a big thing. The second one, I was running. The second one, when I got it, we literally got her out of there with a butterfly net. And I was like, right. I stood there, I was like, you can't. She's pushing her out with a net. And I was like, yeah, so that bird, I can't touch that one at all.
Right.
She'll bite me. Yeah.
Well, you can come visit him anytime you want.
I will.
Take it. It is homeroom now. Yep. You are in the right place. Hi, Mace. What's up?